thank you all first, because I know everybody has a busy schedule, and I just want to thank you all very much and take a little time out to see this demonstration. I would love to tell you that it was all me. I didn't have anybody to help me out, but to tell you the truth, a lot of personal things, a lot of professional things happened the last couple of weeks. Time flew by, and I literally told the students, this is what you're going to be doing, or they actually chose some of the things that they were going to be doing. I said, well, here's the stuff. Figure it out. Come Friday, we're going to do a demonstration. So another thing that happened too is, even though it kind of looks in disarray, a lot of this stuff wasn't even set up until Monday. So I wanted to thank the Media Center, Michael. They literally came in here. They had some extra monitors, extra computers, set everything up, got it all running. The rest of the students literally loaded everything they needed to load, all the instructions. That it was pretty much hands off. I just told them what they needed to do, and they did it. So what we're going to be doing is showing you from Station 1 all the way to Station 5. We try to take everybody through the engineer design process. And one of the things, the bottom line on the engineer design process is, what is the problem? Once you identify the problem, what is the plan to fix it? Then you go ahead and go through and start doing the processes to fix it. You test out that solution. If it works, then you actually build the model. So what I'm going to do is start off with Tina, and she's going to kind of tell you that part of the station that she is. Then we're going to go with Liza, and then we're going to down the road. You can see the process that it moves from the idea, the problem, to the different plans, to actually developing the model, and then we're actually going to start testing the models, and then we're going to end up with Taylor Newsome. Those that do not know Taylor Newsome, he's actually the CEO of SkyView Ag Services, and he's got the big old drone. So he, hopefully if the weather is clear, he's going to do a demonstration outside to show you that you can move from these smaller drones to that big drone out there. But, go ahead. They're shy and they didn't rehearse, so I apologize. So, go ahead. Tell me what you did. I'm going to stand right by you. It's okay. What she has done, Tina right here, is she's shy. I told her, don't worry, I will never set her up for frill. You don't have to be here. You okay? You're not crying, are you? All right. She actually has drawn out everything, because when you identify the problem, there's different ways that you can provide the solution. So some of the ways is actually through Tinkercad, which Liza is going to show you actually how she did block coding. And then Ava over here, there's two different types. Actually, there's several different types. There's actually Tinkercad block coding. There's actually, Ava's going to show you some of the scratch coding. And then we're going to move on down. I'm sorry, my name just drew a blank. Connor Hickey. So don't you think I forgot the name there. But he's actually going to show you how to do the 3D printing. And then we're going to go outside and they're going to show you actually how to test them. And then find out the solutions, rework it, go through the process again, figure out the problem, and then actually run with it. Then we'll culminate with Taylor with the drone. So the second station, Liza, you want to take it?
So my previous station was Tinkercad block. So I used the notebook Dr. Colls handed me, SkyView. He showed me an image, and I built it using the Tinkercad block. So having many different Tinkercad blocks, I figured out which parts looked right to put them in place to build the Tinkercad block. Ava.
Can you switch it over? Oh, she's got it? Yeah, the second thing.
She had Tinkercad block. So she put code in to make animations for things to move. So.
And I'm going to interrupt 1 second. They look very easy, but they're actually a little bit more difficult than what they're actually doing right now. Literally, she'll just take a picture and then build it, and then all those symbols is what she has. So she has to manipulate all those symbols to actually make it look like those parts that they have on there. Scratch coding is a little bit different too. On the back side, you actually have the script so you can go from the coding blocks to the actual script. But Ava, which I had no idea she was so talented with this scratch coding, that you actually make sprite, they call them characters that you make, they're called sprites. So she actually built a story out of code blocks from scratch, which is one of the difficult things to do because I have no idea. And another thing is, I shared with some last year that was my first year last year, have no idea what engineering technology is. A lot of these students, the advantage that they have, they're technologically proficient. They come at an age where all electronics is at their fingertips. So literally, not only last year, but especially this year, because we have more components, as you can see, they showed me how to do it. I mean, some of this stuff I have no understanding. She's starting to show me how to do scratch coding. She built all those things right there. So they don't come just with a character where you can just copy and paste. She literally builds it from block coding. In Liza here, that's a three-dimensional online platform that you can go on. And this is one of the harder robots, which one of Eric would show you how he built that one. And so they take these models, they'll see them on the screen, and then they'll start actually building it over here. Then you move on to Connor. He's going to explain what he did with the 3D printer.
Well, when I started out, I went through a countless amount of websites to help me find a 3D model for the chess piece I'm printing. And I took that from this here website because it had the download file. I downloaded it and exported it out to Tinkercad, which created a 3D model and helped me with it. And when I took that, I turned it into an STL code, which this printer here will convert to G code and start printing it through a little SanDisk that saves these models on there. And each thing has its own like little setting that has to certainly be on to work with this printer. And when you start printing, it'll give you a rough estimation of what percent it's on and how long it's been printing for. So when it's done, it'll tell me how long it took to print it. So like right now it's at 87% and it took about 42 minutes to get to this point.
And this is another one where the computer wasn't even set up. So you obviously have to have the computer and you have to download the software for it. They did it all by themselves. No instruction from me, they figured it out. And I take that back. Mr. Dixon and Mr. Pitts were a big help. In fact, Mr. Pitts came over here and repaired a lot of our 3D printers that were not functioning correctly. Mr. Dixon, I felt bad for me, ran back and forth, helping them out with the 3D printing on there, ensuring that all the dimensions are. But between him and Jax, who couldn't be here today, they literally figured everything out on there. So what we're going to do is, I know this is a little bit awkward, we're actually going to move out, and a lot of the other students are going to take you over and show you the robots that they do. So what they're actually going to show, who had the smaller one? Who had the rescue bot?
He's still trying to fix it.
Oh, okay. Bring it out here anyway, though. Bring the rescue bot. I know it's not working. It's all right. Hey, Jay, what I wanted to show you with this is, with this Vex kit, and I failed to mention Mr. Horn, who helped us out greatly, not only here, but at the high school, purchasing a lot of these things. The versatility of this Vex kit is amazing. Again, these are things I have no idea you can build. In fact, Mr. Dixon, I pulled a lot of his stuff. I was like, how the heck did you even build that? He just says, I look at stuff and I put it all together and then I tell the kids how to build it. And that's exactly what happened. So a lot of his that he builds, he lets me use them, and then my students over here replicate a lot of the same things. So this one literally can be a catapult. So you can take these same Vex kits that do the robots, and then you can go anything from, where's the rescue bot? Go to the rescue bot. No, you didn't. I'm in. I don't care. I want them to see it. See, they get frustrated because they haven't finished it yet, but that is part of the process. It's a frustrating process sometimes because you can build everything and you think it's correct, and for some reason there could be a cable that's not attached, it could be put in the wrong input-output, and then sometimes you have these cradles that is so hard to screw in, and then it doesn't work. But the reason why I want to show you that is because you can start out with something somewhat simple to them, very difficult for me to put something like that together. Then you can literally move into things like the base box, things like the claw box, things like, turn that around. What is that one called? A stack box? What's that? Escalator box. Where's the stack box? So these things are very, very difficult. So you can go from very easy, I say easy for them, to very difficult. So as they learn throughout the year, they'll progress and get into these. Now these are just other robots, not part of the VEX kit system that they built. Yandel, what was that other one? What is that called again? MBOT. MBOT, this one you can't code, remote control. MBOT you can actually download, I think you downloaded it, right? The code for this, you can actually code those. You can actually code these other VEX bots. And then so you could literally change whatever direction just by putting in a code, or you can operate them via remote control when you link it to the computer. So what I'm going to have the students do is actually put it on this, and you can manipulate this obstacle course however you want on there, but we're going to have them demonstrate how these things work. So put them on there and go at it. This one's not ready yet, but it's okay. Brian, put it on there.
Oh, yeah.
Yep, put it on there. Now, some of these you have to operate by cell phone. I asked Dr. Smith permission. They only use it for operating these robots. They know not to use it any other time. But we found a way where you actually can connect it to remote control and not have to use a cell phone. And we don't have it set up right now, but Mr. Dixon had it where they made like basketball hoops, soccer things, so you can get as fancy as your imagination allows you to go. Okay, so before we move on to the next station, thank you guys. People with the drones, move over there. Excuse me. We can kind of step over there. Oh, that was really good. Sorry about that. You can step over this thing here. Okay, since it's raining outside, we were hoping to use the drones out here, but sometimes you have to improvise. So, there are different types of drones. We started off with, in fact, Josie showed me like 3 different drones that we started off with. That gets you very simple to very complicated. The most complicated one is Zane, and he literally put the tri-drone together by himself. Then, go ahead, in fact, you can talk through that part of it.
Basically, Dr. Colls gave me it on the website, and that would be
If you guys can't, well, I was going to tell them this over.
they gave me like rough instructions on how to build it. And I just went like 3 days and I built it. I had like input where I could like plug it into the computer and actually upload it. And it's like with a camera on it, so you can actually see what you're flying to the camera. And as like different fly modes, so like if it starts going like somewhere you're going, you just switch it to just touch off the
All right, if you guys want to start off with the drone. Jace, I would pick that up before somebody steps on it. Are you comfortable with flips yet? No problem. Are you comfortable with flips? Let Jace go, then you go after him. Depending on the drones, they can do flips. They can do a lot of things. They can stop in midair. This one goes up to 70 feet. Is that not working on yours? And these are some of the problems that you'll get a bad connection, especially with the rain, Wi-Fi. So it's okay, but go ahead and try that one. Good. It's a lot easier outside when you got more room. Vicky, can you see, or Taylor's right there, can you see if he still can fly? Okay. All right. All right, flip it. Flip it again. Do it again. Just so they can get a better look at it. All right, Taylor. Taylor, can you see this one? Flip it again.
Bring it up. Get a little close. Oh my.
All right, I want to see your drone do that. All right. Oh, good job. All right, thank you all. All right. Is it gonna be okay? All right. If you, I know, well, two things. You can go under the canopy, or you can watch the drone from here. Either way.
So for those of you that don't know me, my name is Taylor Newsome. I own and operate SkyView Ag Services. This drone in particular is a DJI T40. It's the largest ag spraying drone that DJI currently manufactures in the United States. I use this drone to spray crops, ponds, pasture, any kind of spraying needs that, whether it's agriculture, industrial, it doesn't really matter what the sector is. If you've got something that needs spraying, I can do it with this machine. If you've got something that needs spread, seed, fertilizer, different things. But currently, at the moment, the spreader tank is actually what's sitting in there. This drone weighs about 85 pounds or so, completely empty, with no payload and no battery. When you add a battery, batteries are about this big, they weigh about 20 pounds a piece. When you add that in there, you jump up to around that 100, 110 pound mark. When you add your payload in, depending on whether you're liquid or dry, it'll get you on up there. When it takes off, it'll be around 200 pounds. Flight time on this machine, if it's completely loaded, it really depends on where you're flying. If I'm flying out in the field, it's got really long rows and not any obstacles, or very few obstacles, I can fly for 5 to 7 minutes. If I'm in a small field that has obstacles, or if the drone has to do a lot of slowing down and turning around, it'll eat up that battery and I won't be able to fly very long. So I'm just going to basically fly it. I'm not going to do any kind of spreading or spraying, but I'm just going to fly it down and fly it back. You can see how large the drone is. You can see what kind of force the propellers that are on there. This drone has 16 propellers on it. It has 8 motors, top and bottom on each arm. So I'm just going to take it off and fly it down and fly it back. And if anybody has any questions,
All right.
I really want to fly on it like a hang glider. That would be the best way to get to school. Just right to school on a glider. Iris on a
It actually has computer software which actually takes the picture of the crops, so it'll know exactly where to spray and where not to spray. And if it runs out of battery, it calls it back to the station, put new batteries in, and it'll start back up where it stops.
Sounds like a hair contest. Interior person. Interior person.
No, you can't.
I don't think so.
This is the remote that controls this drone out here. This drone is basically an Android operating system drone. You can back all the way out. You can surf the internet. You can do several different calls with this remote. Main thing though is obviously operating this drone. You can hook it to the internet, but you do not have to have network connectivity to get out here and fly or do any kind of work with it. It's not required. But this is DTI, what they call their smart remote. There's several different kind of buttons on here that don't necessarily do anything for this drone, but you can use this is kind of a universal remote that you have, so you can use several of their other what they call ag drones, ag drones, and there's other drones that you can use different.
What if I told Jason about it?
You notice on the front there's two antenna-like things sticking down on the front of the drone. This remote has an internal and external battery. That way, when I'm working out in the field, I don't have to worry about charging every so often. I really got the batteries, and I also have external batteries that I can swap so it's already on here. So I can zoom out right there.
The fourth period class, I'm gonna open that door, you're gonna have to go back in.
Just satellite. So you can see here, this blue dot, that's what I'm saying. This red, there you go, the drone itself. Well, it's actually the car has to turn off. So what this thing will actually do is I can demonstrate it real quick, but I can actually take this drone off here. It's going to record this as a new phone.
I've been recording, so I have to skip that.
And you can get it anywhere out there.
Well, y'all have to go back and use those days. I haven't done it either.
Me neither.
Just continue to do it while you're here.
Are we gonna go? Start them again.
Can you put Jake on there?
There we go. And it locks it up. And it's done. It's going straight to the power.
I can get out here anywhere in the
People in their apartments like looking out the window, what's going on at the
I get $3 back.
I'll pay $4 for that. $4.
$10.
$40, but I'm not going to.
15. Sounds like a weenie.
Hey, how fast did it go?
It'll go about 33 feet per second, which equates to about 22 miles an hour. When I'm out in the field spraying, I'm running as fast as it goes. It's about 22 miles per hour.